Hello everyone, myself Dr. Sunny Kumar. I am an assistant professor in Department of Chemical Engineering, PKG College of Engineering and Technology, Panipat. I am giving the lecture on the unit process subject. This is my lecture 5. So in the previous lecture we have discussed about the different factors which are controlling the alkylation process. So the sum of factors are the thermodynamics functions, mechanism reaction, mechanism of vapor phase alkylation, hydrocarbons, mechanism of carbon oxygen alkylation. So these four we have previously discussed, but the remaining factors today we will discuss. So the another one is the catalyst and the concentration of reactants, temperature, pressure, and energy requirement. So these are the another factors which are controlling the alkylation process. So now we will discuss each one. So first we will discuss the catalysis. So an apparent characteristic of many alkylation and dealkylation reaction is their slowness. Okay, so generally we know that the catalyst have the property to enhance the um, reaction rate and they reduce the slowness of the process. So it has been necessary to restore the catalysis to make the reaction proceed at a rate that will be feasible. So the mineral acids such as sulfuric, phosphoric, hydrochloric and hydrofluoric are widely employed as are aluminum chloride, ferric chloride and boron fluorides. These are some examples. And with wide variety of catalyst alkylating agents to choose for to form the this type of alkylation of process to occur and for the desiring product. So the choice of this agent to use will depends on the relative cost and the reaction rate, which will give a fruitful results. So now the catalyst have a very important role in the alkylations. Okay, so we have talked about the different H2SO4, HCl, hydrofluoride, the aluminum chloride, ferric chloride. These are some catalysts which we are using for enhancing the reaction rate and the cost of the process, reduce the cost of the process. Okay, now we will discuss about the concentration of reactant. So how much concentration we have to give initially to increase the higher production. So an excess of the methylating agent act frequently to the better yield. This true when the less vigorous alkylation agent such as the alcohols are employed. So in the preparation of this dimethyl or diethylaniline, such of use of excess of the alcohol tends to lessen the formation of the monoalkyl derivatives. So the diethylation of aniline is more difficult than the demethylation. So this is the disadvantages for this excess alcohol. So the currently the procedure is to separate the monoethyl aniline from is the diethylaniline by benzylating the monoethyl aniline to benzyl ethyl aniline and then distilled it. So it is also very important part. So we have to remove the excess amount of alcohol to give a maximum product and to react with and produce this this diethylation. So since one of the two methyl group in dimethyl sulfate acts more vigorously than the second, it is better to proportion the reactants to use only one methyl group in difficult alkylation. For certain energetic alkylating agent, it is advantageous frequently to dilute them in order better to control the reaction. So this is the important line. So we have to focus on this. So the for dialkyl sulfates, the addition of this alkyl speeds up the reaction, while for alkyl halides, so this dialkyl sulfates increase the speed of the reactions. Now, so alkaline media are often too fast. So here the alkylation is conducted in an acid medium to retard the reactants. In some cases, it may be necessary to maintain a low concentration of one of the reactant. So that can also the controlling factor in the manufacturing of alkylate in the petroleum industries, where an isoparaffin is treated with an olefins. So the olefin is diluted with the isoparaffin to lower its tendency to react with the itself by the polymerization. Example, keep butylene from forming diisobutylene. So the concentration of the reactant is very important role to produce the desired product. So we have to choose in the a specific concentration for our reactants, which can control the our maximum production we can get. So in many intents, there is more than one place in the molecules where alkylation can take place. This is true in methylation of morphines to codeine, where an alcoholic hydroxyl, a phenolic hydroxyl and tertiary nitrogen are present. In such cases, it is necessary that only the theoretical amount of the alkylating agent to be used, or that special condition be employed. Whenever possible and necessary, on-off reactants should be added as a solvent. So, since this not only brings the in mass action effects, but the simplifies the recovery because of the absence of any extraneous substance. The principle is used in making alkylatic benzene, dimethylaniline and alkylate. So it is also another way. So if we directly use a reactant as a solvent, so the non-reacting solvent are used such as the nitrobenzene, carbon tetrachloride and chloroforms, which are not participating to the reaction. So that will be the another factor we can use. All solvents should be anhydrous, because water can create the to reduce the production of the desired product. So a solvent may cause product or byproduct to crystallized out. So when the dimethyl sulfate is employed for a certain alkylation, it is dissolved in benzene and added to an alcoholic solution of sodium phenoxide derivatives to be alkylated. In the presence of these solvents, sodium methyl sulfate is very little soluble and it is precipitated out. So it can easily precipitate. So it is also the using of the specific solvent can also a very important role for the desired product, and so this is one of the example of it. So this procedure tends to good yield, the maximum yield you can get. So similar conditions are applied to the other alkylating agents. So these solvents are very important role for producing the desired product. So now the concentration of reactant, the previous controlling factor which is for the alkylation. Now the another factor is the temperature, which are also impact of the process. So when such alkylating agent as methanol, ethanol, ethyl alcohol or the alkyl halides are employed, a much higher temperature is necessary than that required with dimethyl sulfate or diethyl sulfate or even methyl p toluene sulfonate. So these components required higher temperature. So temperature are also very important role. So the methylation of aniline to dimethyl aniline will takes place at about 200 degrees C. So alkylations that are carried out on the vapor phase call for much higher temperature of about 400 degrees centigrade. And when the isoparaffin are alkylated with olefins, ordinary temperature is employed with the hydrogen fluoride catalyst. So for the different reaction we are getting the different different temperature for the different alkylation. If you are using the different products, so we have required the different type of temperature. So that range may be the ordinary temperature, at the room temperature it can possible, or at the 200 degree, or it is higher that temperature alkylation process can happens. So the temperature is also very important controlling factor for this alkylation reaction. So now but refrigeration is required with H2SO4 because it is a exothermic reaction. Catalysts are lesser tar formation. A number of alkylating reactions are exothermic, so we have to cool process. Example, when amino antipyrine is methylated with methyl bromide to give aminopyrine. Here cooling is advisable in the early stage of the methylation. So increased temperature frequently cause migration of alkyl groups to an aromatic nucleus. So this alkyl group can be transferred to the other molecules. So the dimethyl aniline sulfates gives N-methyl p-toluidine. So this compound can gives. So we have seen the effect of temperature. For the lower temperature what will happen, and the higher temperature what will happen, and if we are using a catalyst and any different catalyst, so like H2SO4, so that can also we have required the cooling for the system, because that reaction is exothermic reaction, and so we have to cool the process to produce the maximum product, otherwise the byproduct can produce. So that is a temperature effect. So now we will talk about the pressure, how the pressure can affect our this alkylation reaction. So in most alkylation the number of molecules decreases during the course of the reaction. So in these cases, according to the principle of Le Chatelier, the pressure favors the alkylations product. In other cases those involving the lower member of the alkyl halides as alkylating agents. So pressure is used to keep the reactants in liquid phase. So this pressure is also very important parameter for you can do the reaction at the liquid phase, and this Chatterjee principles suggest that the alkylation favor when the pressure will be high, and you can get the better product. So this is the effect of pressure. So now we will discuss about how the energy requirements for during the alkylation process. So in presenting the power requirement for any unit process, not merely the energy of reaction should be considered, but also any externally applied energy needed to bring about the reaction. More electricity or steam is required for heating or power. It's a must necessary to consider as part of the cost. If energy requirement will be the more, so the production cost will be increased. So that is also very important. If you are producing any product and that's requires a higher temperature or higher energy requirement, so the cost will also increase. So the energy of the chemical reaction must be known or determined at least approximately before the reaction is transferred to the commercial scale. If if you will produce in the commercial scale, the large scale, so the cost will be very high. So the product cost will be very high during that, and so then it will be not feasible, or nobody, the customer cannot afford to purchase that product. So that will be also energy requirement for the system is also important. So in order to that equipment can be adequately designed as a matter of experience, alkylation as a class are not large energy consumer. So except those such as thermal alkylation, in which high temperature and pressure are necessary. This is one of the reason why this process for production of gasoline was unsuccessfully in competition with similar catalytic alkylation, because the hydrogen fluoride carried on at nearly atmospheric temperature and pressure. So the energy requirement are very important for this alkylation process. So today we have discussed about the other factors which are affecting our alkylation reactions. So what are the factors which are controlling this alkylation? So in the previous lectures we have also discuss these factors. The first one is the thermodynamics functions, and the second one is the mechanism during the alkylation. What are the mechanism? So that we have discussed, and this mechanism of vapor phase alkylation of hydrocarbons, that we have discussed, and this mechanism of carbon oxygen alkylations, that is also an important factor. And this catalysis, the chosen a specific catalyst can reduce the cost of the products, and they can also improve the reaction rate. So that these are the factors which can affect, and the desired solvents that can also important role for the alkylation. And the concentration of the reactants, it will be high, as we have seen the alcohol concentration is more. So only the mono alkylation generally happens. So we have required dialkylation, so it is not possible. So we have to choose a specific type of solvents or this non-reacting solvents we have to use, like chloroform or trichlorides. Sometimes these are different type of solvents we used. So the specific concentration is also important for the production of the alkylation. So, and the temperature for the higher temperature and lower temperature, and if you are using a catalyst which is H2SO4, so they are in the reaction, they are exothermic reaction generally happen. So we have to cool down the reaction, so refrigeration is also requirement. So the temperature also play a good role for the controlling the alkylation reaction. And the pressure, so the pressure we have seen, Leach arterial rule represents that the pressure for the higher pressure gives a alkylation, good production of the product of, and the reaction will be good, the yield will be high when the pressure will be high. So that is also important role in for the reaction. And energy requirement, if the energy requirement will be more, so the production of the product will be high, cost will be high. So we have to reduce, initially we have to calculate how much energy we have to require for the system. So for the commercial scale, so initially we have to know the energy requirement, otherwise that the product will not feasible for the production. So that is also important role for the alkylation. So we have to require the specific catalyst for that, for reducing the energy cost. So all these parameters are very important for the alkylation system. So in the next lecture we will discuss about what are the different type of equipment are using in the alkylations. Like the heat exchanger or reactors, which type of reactors and the heat exchangers are using for the alkylation. So how we can reduce the cost, and what will be the design of this. Also the material of constructions, and the corrosion of apparatus. So how we can a suitable type of reactor or the system we have used to give a maximum production of our this alkylation reaction, and the what types of equipment and recovery of alkylated products we have to use, and the safety, what are the safety requirement we have used. So these are the parameters we will use in the next lecture. So thank you very much. Now if you have any doubts, you can ask me in chemicalscenario@gmail.com. This is my website. If you have any doubt, you can ask me. So we will meet in the next lecture. Thank you.